Imagine a vivid red slab of meat placed in the middle of a 15th century ocean. No refrigerator, no ice, no vacuum-sealed packaging, and yet it survives for hundreds of days, resisting decay and foul odor. This paradox defies biological logic. Meat, by nature, is fertile ground for bacteria. Within
Make sure the
hours at
salt
room
reaches
temperature,
deep, or it will spoil.
protein-degrading enzymes
know.
awaken,
The smoke will help
microbes
too.
multiply, and decomposition becomes inevitable. But our ancestors discovered a way to stop time not with magic, but with crystals of salt, large grains, roughly the size of barley kernels, scattered across the meat, instantly created an entirely new ecosystem, dry, sterile, and silent, locking microscopic life into stillness. The strange truth is that salt does not kill them. It simply makes life impossible. This is not folklore. It is pure physics, a battle of water molecules, osmotic pressure, ionic diffusion, and protein architecture. A war in which the only defeat belongs to life itself, while victory belongs to order. To understand how salt can preserve meat for months, we must begin with its shape, the geometry of its crystals. Under a microscope, each grain of salt resembles a perfect cube, with flat reflective faces and sharp angles like the work of a microscopic architect. When people once spoke of corned beef, they were not referring to corn kernels, but to corns large, uniform salt crystals roughly the size of barley grains. This size is no accident. If the salt is too fine, like sand, it dissolves too quickly, penetrating the meat abruptly and rupturing muscle fibers, leaving the surface soft and wet. If the crystals are too large, osmosis occurs too slowly, allowing bacteria to multiply before being locked in place. Corn-sized salt reaches an optimal equilibrium, dissolving gradually, creating a transitional zone where water escapes and the surface slowly dries, forming a stable protective crust. In other words, each crystal is a brick, and the meat is the foundation. When the bricks are sized correctly, a wall of salt emerges, a barrier between life and decay. That is why a slice of meat can sleep for months while the outside world continues to move. At the molecular level, salt operates as an invisible machine driven by the physical law of osmosis. When salt concentration outside a cell exceeds that inside, water moves through the cell membrane to equalize pressure. Imagine bacteria as merchants, their cargo being water. Salt does not kill them, it bankrupts them, draining their resources until they shrink and cease activity. This is the absolute dryness of life without water. No reaction can occur. Enzymes, proteins, and DNA, all structures that depend on an aqueous environment, begin to deform and halt. Salt does not stab, burn, or poison. It merely removes water until all motion stops. Large salt crystals dissolve slowly, maintaining stable osmotic pressure over many days. This slowness makes preservation sustainable. A salted piece of meat does not die instantly. It enters a prolonged sleep where time is no longer measured by temperature, but by dryness. When salt concentration reaches saturation, a unique microenvironment forms around the meat, one where microorganisms lose every familiar force of interaction. Osmotic pressure becomes so extreme that bacteria drift as if suspended in a vacuum. They cannot swim, metabolize, or replicate DNA. This state resembles weightlessness in space when forces balance. Motion disappears. In saturated salt environments, water activity drops below 0.75, a threshold where most microorganisms cannot survive. This principle underlies all preserved dry foods, from dried fish and fermented sauces to smoked meats. Ancient people did not know the term water activity, yet they sensed it through experience cure until the salt no longer dissolves. At that point, the microbial ecosystem vanishes, and the meat enters equilibrium, no decomposition, no fermentation, and no evolution. It is the moment when salt defeats time. Not through destruction, but through absolute stillness. Salt does more than draw water outward, it also infiltrates the muscle structure, where protein fibers twist like ropes. Sodium Na- and chloride Cl- ions slip between hydrogen bonds, loosening the old structure and rearranging it into a more stable form. Imagine a damp rope soft, tangled, prone to decay. But once tied into a knot, it becomes stronger. Salt performs this exact action at the molecular level, knotting protein fibers, making the meat firm and resistant to deformation as water leaves. That is why salted meat can be dry yet supple, chewy yet not brittle. This transformation resembles the curing of leather, where salt stabilizes collagen and prevents natural breakdown. In essence, salt preservation does more than suppress life, it redefines matter itself, turning an organic object into a stable form that could endure for centuries if conditions remain unchanged. In this way, salt is perhaps the greatest sculptor in chemical history, not by creating new shapes, but by preserving the old ones forever. When we look at a slice of dried red meat under the light, we are not just seeing food, we are witnessing proof of how humans learn to control the motion of nature. All life requires energy, and energy exists only through movement. By removing water, the medium of motion salt transforms life into a motionless monument. In the age of refrigeration and chemical preservation, we often forget that the earliest preservation technology was simply the art of stopping movement. The immortality of meat does not lie in DNA or machines, but in the crystal structure of salt, an inanimate object that knows how to make the universe pause.